somebody stepped on this.
Okay.
The software thinks it's on, doesn't know it's running.
Yeah.
Until it's actually reading current from the current trap. So then, you know, you really want to check that.
Right.
Where's the current? Right here. So if I kind of, so this is rough pump enabled. If I click over here, it should be rough pump enabled with a D. It tells you that it's on. All right. So this is your 4-line gauge right here, PC roughing pressure. This is the gauge which is located. Here's your 4-line gauge right here. So, you know, you can check that it's enabled, it's drawing current. You can check that it's actually obtaining 4-line pressure. Someone could be standing on this, on this hose, you know. So,
Seems like something.
so then what I would do is I would turn the turbo backing valve on, and my turbo is being backed. I would put 100 in here in this box, 100% speed, and turn on the turbo.
Oh, you turn on, just press this one?
Well, no. So this is on, it's green. This is on, we're drawing current. We have 4-line pressure.
Yeah.
This is our turbo backing, this is on, and our pump is on. I'm just explaining how I would do it outside of the recipe. Turn on the pump will increase in speed until the at speed signal illuminates. That usually happens about 97–98% speed. Once that's at speed, you can turn off the turbo backing, wait for your 4-line pressure to drop down some, turn on the PC roughing valve. Now, a couple things with this. You'll notice that there's some green indicators here, vacuum and door closed. This thing, Warren pointed it out. This is for your glove box, okay? So, I think these switches are all in series. This is your door switch here. But over here, you'll notice, there's 2 switches. They're vacuum switches. They have red, black, and white indicators on. So those are 2 vacuum switches in series. The reason we have 2 of them is for redundancy in case one of them fails. And all those are is a diaphragm. So diaphragm flexes, you change the state, it goes to on. Whenever you vent it, it flexes, change the state, it goes off. So we use that vacuum switch for really 2 reasons. Well, 3. One, whenever we first pump down, let's say the viewport's cracked or the door isn't sealed, if the vacuum switch doesn't engage, you know that something else is leaking. You have a bigger problem. And the recipe will time out. It won't pump. Whenever we vent, we check for that to extinguish, so you don't constantly throw nitrogen at it. You know, because if this isn't loosened up, and whenever I do pump, what I do then is I just back this off a hair so that it isn't compressed. So when it does vent, it gives you an escape path because we don't have a burst disc on this.
Right.
So, you know, we use it for that reason. We also use it for the Rigel controller. So this Rigel controller is pretty sophisticated in that we execute a recipe from here, and we send it down to the controller. The controller, well, we actually write the recipe here, send it down to the controller. It's the controller which executes the actual steps, turning on valves, shutting things off, checking pressures. And we call this Eclipse software. There's LabVIEW software within here, and there's a software package in between. It's called the host. And all it does is it's the middleman that talks between the 2. Now, one of our selling points was, and I kind of shake my head with this, was like, hey, you could push a recipe down and smash your computer, and it would still run. I'm like, well, why would you want to do that? But we're one of the few manufacturers that I believe have a real-time controller on our systems. And what's nice about this is that because it's modular, I was showing the back with all our bricks, that it's just plug and play, and it executes. So, you know, that's a real nice feature. And it also has the embedded EMO and the start circuit in here.
So right now, because everything's controlled from here, we don't need to touch that.
We don't do anything from the front facing. I know other systems, you can run these remotely, local, you don't do anything. Because if you start to do that, it's not going to communicate anymore. Because, you know, we don't have it in local mode, we have it in serial mode. So yeah, you just want to, other than turning it on and off, which you don't really need to do, yeah, you don't do anything with that.
Which one is on and off?
So are the interlock systems are on the machine side? Like, can we create a recipe that will screw it up, or will the interlock still catch us there?
I'll actually show you that. So we have I talked briefly about conditions, which was the high back L.
Right.
So let's actually talk about interlocks. It's a good lead-in. Then I'm going to go ahead and I'm going to shut this down.